That was a really interesting, I don't know, really interesting response by Dr. Gertzel. I'm wondering if Anders was paying attention to all of that and if he has anything to say.
Well, there is so much to comment on, of course, to unpack there. And I think there are two parts that are in particular caught my attention. One is this issue where Ben disagrees with Nick about how to go about handling it. And I think it has to do with prior probability estimates and guesses on how does the risk landscape look like. So Ben points out that if you have a situation where it's enough that there is one bad AI research, then big things happen. This is very much the problem we outline, Nick and me, in a paper we call the unilateralist curse. If you have a group of agents that it's enough that one agent can unleash something, then even if all agents are nice and are trying to do it only if they think it's a good thing, as the group gets larger, it's more likely that somebody's going to be that guy. So I think this is a situation one should recognize, and when you're in that situation, you should try to be more conservative than you normally would like to be, just because of the nature of that situation. But I think in particular, when you really want to regulate is when you can't afford to be wrong even once. And there are those people in AI safety who really think that, yeah, we are very close to that. Hard takeoff scenarios and likely in a bad outcome of such a scenario. That means that we have a sharp cliff edge, we must be exceedingly cautious. I'm way more optimistic. I don't know if that actually is based on any rational reasoning or anything. So I don't trust this conclusion very deeply. But I think actually it's a more benign domain. And I think Ben also have roughly the same view here. So this, of course, leads to different ideas about what you want to do, regulatory speaking. However, it also suggests that if we could get even a slight bit of better information about the actual risks, the actual structure, the actual probability, we would win so much. So I think that is another reason to really, really pursue this. Then another interesting point he made very briefly was the resource constraints that have shaped the brain. Once you're free of them, you might reshape it in a lot of other ways. Again, just to mention a paper I wrote with Nick, we did one about human enhancement where we looked at evolutionary medicine as one guide to try to see where evolution really might have constrained us. And those are the areas where we might then find ways of unconstraining us in a constructive way. There might be other domains where it's going to be very hard to fix things. For example, I think even uploads are going to have to run sleep simply because our memory consolidation is so based around that, which would be tremendously annoying from some perspective. But on the other hand, yeah, it's going to take a lot of reverse engineering to get there. So that was just two main points on Ben's enormous discussion.
Interesting bit there about whole brain emulations and sleep. You know, that's one of the things I actually happened to think about, which was if you have the freedom to change the way that you change synapses, if you look at what sleep is actually trying to accomplish, if you've got your consolidation and you've also got the, say, in REM sleep, bringing up older memories and mixing them in and doing some kind of interleaved learning and that sort of thing, there are alternative ways to do that. And for one thing, it certainly doesn't have to take quite as long as it normally does. So I imagine that there may be ways of getting around those sorts of limitations.
I totally agree, but it's going to be a lot of tinkering.
Absolutely. And that's where, yeah, I mean, Ben is absolutely right, of course, that it's much easier to come up with an artificial intelligence of, you know, that is free to develop in whatever algorithmic method it likes to get it to self-improve faster than an evolution, a patchwork that was evolved like the human brain. I think it might have come across to him as if I were saying the opposite, but that wasn't the case. I was just putting forward, you know, the question, well, can whole brain emulations even rapidly self-improve? Is this something people should worry about, since that sometimes got brought up? Mallory, how did you want to proceed? Do you want to take a question from the audience first, or how would you like to go?
Yeah, we do have some questions from the audience that I'd like to ask. We have one. Their username is SAFT-SOS. Here they're quoting Descartes, "I think, therefore I am." Does that not mean that all physical laws and natural laws are just in our mind? And I think maybe what they're trying to say is our interpretation of physical laws limited by our biological brain? And I also like to tack on to that, how do you think that will change if we were able to have a whole brain emulation and possibly merge that with AI? How would physical and natural laws then be interpreted?
Yeah. So this is, of course, familiar territory for most introductory philosophy courses, where people start getting confused. Quite a lot of people naturally think that, oh, there's nothing problematic with my perception. I'm seeing reality as it is. And at this point, the gleeful philosopher will start bringing up optical illusions and the examples from quantum mechanics. But at the same time, I think David Deutsch has an interesting point in his book, The Beginning of Infinity, where he points out that the reach of our minds is way bigger than what you would expect from most evolved systems. We actually have some mental tools that allow us to actually get explanations that work over shockingly large domains, even though we don't have direct access to them. When we talk about the distribution of galaxies in the universe, in many ways, we can't see the galaxy. We can only see them if we use telescope. So in some sense, nobody has ever seen the Virgo cluster because you can't see it with the naked eye if you are a human. Yet, I don't think anybody would say it makes sense to disbelieve in its existence, or say that, oh, the Virgo cluster is a kind of weird artifact of having telescopes. So I think what you get the same situation even if you're a brain emulation. Yeah, now you might be seeing using a camera connected to a device driver, connected to the various pieces of software, turning it into neural signals. You add extra levels, but as long as these levels don't distort things and are relatively faithful, I think you actually have something that makes sense. And I do think we can build on top of this. I think we can. The most obvious thing is, of course, adding new senses or trying to link up modules in our minds so they are functioning better. If I could just run a quantum mechanics co-processor and have it seamlessly connected to my cortex, that would be wonderful, and maybe I would finally understand stuff. I would also have to change myself, how I work, but that might be a relatively low-level thing, like changing how I visualize things in order to visualize more dimensions, rather than changing the true core me. Of course, philosophers will always throw in, well, maybe there are things that are absolutely impossible for minds of our kind to think about. And I think that's true, but it might actually be relatively uninteresting. It's not too hard to construct Gödel sentences that certain systems reason, but that doesn't mean that they come up that often in practice.
Would anybody
Yeah,
else like to answer that?
I kind of want to jump in on that just because it's a good point you brought up, that it's interesting that our brain can handle things.
Hmm. Sounds like Randall might have lost internet connection. Let's see.
Hmm.
All right, I can hear you now and see your video.
You can hear me?
Mm-hmm.
Oh, okay. So then I don't know what happened there.
It must have just dropped for a second.
I was just trying to say, to expand on what Anders said about the brain being able to deal with things that it wasn't originally evolved for. It's interesting to see in which ways the tools that the brain has are applicable that way. And just to, to point out one little thing in this gelatinous blob here. Say, for instance, the grid cells of the entorhinal system. We talk about them as something that helps map out space. But the same part of the brain, it feeds right into the hippocampus, also as a task, as in humans, it just generally manages to store new episodic memories, new conceptual memories, concepts. Now, the interesting thing is if you take this the system grid cells for mapping out spaces automatically, basically putting vectors along them and saying, okay, this is X and Y, and I'm over here and I'm over here, and coming up with where you are. If you take that and you apply it to more general concepts, something that has nothing to do with space, you can map out any new kind of idea, any concept that you have, and suddenly apply it in ways that you never could before. You can work with it in a sense, mapping things that shouldn't normally be mapped or that you don't encounter in nature. And I think you take that all across the brain and you can see that, these systems, these tools, just like, a deep learning isn't something you can only use for one task. You can use it for many tasks. The same way, all of the tools in the brain can be applied to many different things. It's true, but then at the same time, it's not necessarily optimized for rapid self-improvement. So I think Ben has a point there as well. One thing I wanted to address briefly, because Ben has a certain style, how he expresses his opinion on these matters, is he often makes a very good and positive statement. He'll say something that he really hopes is the outcome. So we hear a lot of very positive scenarios from Ben. And in fact, both sides, of course, want us to end up in the same type of outcome, a good outcome, whatever that good means. It's just that for some reason, the methods that they advocate are very different sometimes. And a lot of this has to do with trying to understand what the probability of certain outcomes are. And those probabilities are influenced by where you begin. So Anders already mentioned that, your bias, and perhaps by intuition, which is, of course, again, biased by your experiences and by your emotional attachment to something. So it's really a problem of clear probabilities lacking in this case, and we don't really know which scenarios are going to happen. Maybe this is just a sign of how early this field is, how young this field is still. But I do think one point that Ben makes is very interesting. He brought this up in his paper in 2015 as well, the one that I think I might have mentioned somewhere. That we may need artificial intelligence, artificial general intelligence, to guard against some of the bigger risks that we run into because of the way humanity goes about things. We'll talk about how an AI might want to follow a certain goal and keep on improving towards that goal, even if it has to consume all the resources in the universe. You could make a very similar argument for humans. We're still based on a system that evolved 2 million years ago, and we're about to use up all the resources of the Earth in order to try to keep doing that, because that's what we were programmed to do. We may also be stuck with the same utility function and following it, and we may be running a great risk of doing damage to ourselves in the process. Now, again, this isn't, I don't know if that's really what's going to happen, but this is part of the argument that Ben is making. Humans are not rational actors. We're not necessarily picking the best outcome all the time. AI may be more rational than we are. So it's entirely possible that developing that as quickly as possible may be something that saves us from a risk that is more immediate or bigger, because we keep on not having a good chance at comparing these probabilities, than the likelihood that AGI itself will somehow be an agent that takes us down. I don't know if I agree with his point of view more, or if I agree with Nick Bostrom's point of view, but I'd love to hear Anders kind of give this a shot.
Yeah. I've been thinking a lot about what can we do to do the research right, because as you said, we need to get the probabilities right, but we might also want to get the values right. So in my current project, this big book about the long-term future of humanity, one of the parts that I'm still working very hard on, and that is tough to work on, is, of course, what values make sense in the universe. And what would rational actually mean? Because yes, we're definitely not rational right now. But just like the hippocampal place cells allow us to handle spaces of quite arbitrary shape, our minds are actually able to handle quite a lot of different models of rationality and thinking. It's just that we're not super good at some of them yet. So it seems to me that one way of making progress on both of these kind of tough problems is one is to look at toy problems. You take a stylized small problem. So this is how you might help AI safety move forward. You demonstrate that here is a little grid world situation and you want your agent to behave itself in a certain way. Can you program it to do it? And that's useful not just to entice software engineers to realize that actually it's harder than they think to make AI safe. But it also is a good way of revealing tricky problems, learning about the size of the problems, and learning about what other questions you want to do, because typically you need to refine this as people find ways around what you wanted to do. There is another side, and that is the empirical research. You actually want to go out in the world and actually watch real situation, because that keeps you honest. It's quite important to not just spend your time in the lab or in the thinking chair, but actually go out and try to get some data and then critically judge it. Just because people think autonomous cars should be driving in particular ways doesn't mean that's the ethical thing to do or the smart thing to do. But it's an interesting input. And then ideally, once you have both good models and the empirical data to play around with, you can also start building the more deeper theories. And I think this goes for using creating AGI that is helping us make good choices. We need to know a bit more about what good choices are, both from a kind of rational and ethical standpoint. But we also actually want to develop, can we make decision aid tools, even in less ethically fraught domains, that are actually useful? That's not entirely obvious yet. Yet there is a big market. You can make a lot of money if you make a good decision aid. And there are researchers working on kind of moral decision aids. I have some friends in Oxford working on that, where hopefully they would tell you if you have a dilemma, well, given what you claim to believe, this is what you ought to be doing. Do you want to discuss it more? And I think that could be quite useful. So I think there is an interesting big research project here. It's kind of spanning not just AI safety and brain emulation, but quite a lot of other stuff, of taking what starts out in philosophy, making it concrete enough that we can start writing code and doing a psychological service, and then start thinking broadly about how to implement tools to make us better.
All right. I think that was a great answer. Next, we have a question from Dean Horak, and it's actually one of my favorite questions to talk about. He says, assume we have substrate-independent minds available on some digital whole brain emulation platform. It would seem that accessing someone else's memories and experiences and thoughts would be nearly as effortless as accessing our own. Given this scenario, wouldn't we eventually lose our individual identities and ultimately become like a hive mind?
Well, I think to some degree we have already created tools to access, yet we actually deliberately create walls. In some sense, internet allows any computer on the internet to talk to any other computer. But it's not just that I can't get your data out of your computer, but we also deliberately create structures like web pages or Google Hangouts to actually shape it. Because having everything in a big pile is not very useful. My memories are only useful because I did make good association in relation to my current experience, etc. And if you had my memories and my memories, sometimes, of course, they would overlap in a resonant way, but quite often it would probably be just arbitrary. So we want selectivity, we want filtering, and that is probably what it's going to mean, that hive minds are probably going to be more limited than they think. In fact, you can compare to economics. Why do we have companies and firms? And of course, economists have been going on about Coase's theory of the firm, and you have Cesar Hidalgo at MIT. And the general argument is that there are economies of scale up to a point. It's a good idea to get a bunch of people together, but you also need to manage the information flow, and then you create a little box around and call this a department or a company. And we are likely to do the same thing for group minds. It wouldn't surprise me that once you have the ability to link minds, we're going to experiment endlessly with a lot of architectures. And some of them are going to be good for certain things, others less good, but maybe specialized. And then we might actually have this big, complicated structure of overlapping and sometimes hierarchical, sometimes autocratic, sometimes totally alien structures. It's going to be pretty exciting. But again, it's a good thing that there is an undo button if you're brain emulation.
Yeah, great point about the undo button. It's something I occasionally mention when people ask about, this is so risky. How would you like experiment with upgrading and stuff? But yeah, you mentioned here, say, things that are already a bit like hive minds, organizations and groups and all that thing. And I think that, to answer Dean's question, I think that hive minds emerging is probably unavoidable because it's already a reality. It's just that the components of a hive mind don't know they're in a hive mind, or maybe they do, but sometimes they don't, or they don't admit it. They'll say, I'm still an individual, but really they're entirely dependent on everyone else. I mean, do you farm? It's sort of, yeah, we may be part of a hive mind and not know it yet.
That was great. I definitely see it that way, that we are already kind of interconnected in a certain way due to technology and social media, and whole brain emulation will just exacerbate something that's already happening.
But also the problems of social media actually give us a very good inkling of that. Just connecting everything completely, that's not very good. We actually want to create the right kind of structures, and finding the right kind can turn out to be amazingly hard, while the underlying technology is relatively simple.
But then if you're taking social media as the example, then maybe it's also demonstrating that it takes a certain amount of trial and error and learning, because we had no idea what this would be like before we got into it. We didn't know what the internet was going to spawn, and we certainly didn't know anything about social media back in the 80s, 90s, or before. So it would have been very difficult to think ahead and say, when we design social media, what should the boundaries be?
I totally agree. There is this general problem that the world is much more complicated than our minds. So we generally quite often can't predict the consequences outside this particularly simple domain. We just have to do experiments, which is, of course, problematic if experiments are risky or expensive or painful, but also very exciting because it means that we discover new things. I find it very unlikely that we will ever enhance ourselves such a degree that we can just figure it out all rationally, just like some philosopher king sitting in his armchair knowing everything. I think we're going to find that a world that has great minds is going to be even more complicated anyway. After all, social media among smart superintelligence is going to be probably having emergent weird properties that we can't think about and they can't think about. They're going to be equally confused when they get their counterpart to fake news or Twitter storms, and are going to perhaps wonder, maybe we need a bigger mind to figure this hyper social media out.
Yeah, it seems like there are, at least two different ways to go about preventing the worst case scenario. And one of them is you try to anticipate something bad that could happen and just don't do it or prevent it from happening. And the other one, as we just mentioned in the case of experimenting with whole brain emulation, is undo buttons. So what we haven't really talked about, and maybe it's because nobody thinks it's possible, is undo buttons for things that happen in AI development. I guess part of the problem is that we imagine that a bad scenario is one where AI development suddenly goes so quickly that there's just no way to stop it, let alone undo whatever happened. But an undo button would be nice if such a thing were possible outside of a sandbox, let's say.
So I think the problem is that many of the AI risks are seen as information hazards. So once I publish my code on GitHub and tweet about it, there is no way of getting the genie back in the bottle. And that is an interesting thing, because that might just be because we're not imaginative enough to come up with a better undo button. There are ways of handling information hazards. I'm working on some projects of thinking about how institutions like the Future Humanity Institute should organize its own research when it finds some risky information. And you can certainly have structured transparency where you can reveal certain information but not others in a way that is trustworthy, etc. But it might also be that we can find ways of doing AI research where you can build in some forms of undo buttons, like we pursue a certain line of thinking, we discover certain risks or certain problems, and there is a considered way of removing that. This is, of course, what we would like to have in science too. If I write a paper that I then later retract, ideally all papers citing that paper need to get a little marker in the citation that now we're referring to a paper that turned out to be wrong for one reason or another. We need to build an infrastructure for that. And right now, I don't have any idea how to do that, but it sounds like one of those things that should be a high priority for some people.
Yeah, actually, this is something where blockchain gets interesting. A ledger that you shared, because if you can actually track everyone who is on that system or who's got a copy of something, then you could go in and try to withdraw it or withdraw the ability to run that thing or to change it to whatever needs to be fixed. That's one approach. I'm just talking about it very loosely because I'm not actually someone who develops that sort of code, but it sounds to me like something that those systems could evolve towards. And the other is what we call software as a service, right? If you look at that, the situation there is that if, let's say, the service that you're making available has a bug, you only need to fix it where the service is being run and everyone else uses it and puts it to use. So if there are all these little modules that you use for AI, but they're all software as a service, it's very different than if you're giving away the code. So some opportunities there, perhaps, for something like an undo button.
Yeah, sounds like a really fun topic to pursue further.
All right, I think that might be a good question to end on for our workshop, unless anybody has any objections.
Yeah, I guess let's ask our panel if any of you have any questions that you think really should be mentioned, either because they're your own or you saw them coming through, maybe Jesse or somebody noticed something coming through, just as a quick opportunity before we close. But otherwise, I agree because it's been long enough. And we can still handle all of those questions later in other ways because we've got them all written down.
Doesn't sound like it. So I guess that'll be the conclusion of our workshop. Again, thank you everybody for attending. I want to say thank you to all of our volunteers that helped put this together, and all of the speakers that joined with us today, talked on the panel and sent us videos or did interviews. We really appreciate that.